In this video, we are going to discuss question number 7 of the CSET January 2024, paper 2, number 7. And as you can see, it stems from a sequence of 4 ships. As you can see, there's a progression as we go along. Ship number 1, 2, 3, and 4, the number of black and white counters are increasing in that pattern. We discussed that in part A. Here's the solution, and we discussed part B1 and 2. So now we're going to part 3 now. It says we've got to complete this expression so that we can get a total number of counters T to be expressed in such a way that N will be the number of ships. So we have to generalize. Now we have to look at the pattern. 1, 2, 3, ship 1, number 1, ship 2, number 2, ship 3, number 3, ship 11, number 11. So ship N, there will be N, and 1 is constant. When you open the square bracket, that 2 there is constant. But now it has to multiply to N, the ship number, and the 1 is constant. Okay, so let us do this. So in this cell, we'll have an open curve bracket, open and close curve bracket, the ship number N plus 1. Then open and close a square bracket. And then we've got a number 2, which is constant. Open a curve bracket and put N, close bracket, and put a plus 1, close square bracket. So let us simplify this expression. So what we're going to have, N plus 1, that times 2N plus 1. Okay. And then we've got to expand this out, N times 2N. We have 4 multiplications to do. 2 with N and 2 with 1. 2 with N, N with 2N, N with 1. And then 1 with 2N, 1 with 1. So N times 2N is 2N squared plus N, because that's a plus N times 1 is N. So now we have to repeat this, but with 1 now, that number 1. 1 times 2N is 2N. And 1 times 1 is 1. So now we have to simplify. They call that expanding to obtain a quadratic. As you can see, 2N, 1 plus 2N is 3N. So what we have now is a quadratic expression. The quadratic because of the little 2 that is above the N. Okay, so that's supposed to be the answer for the first cell, but we've got to leave it that way. Let's leave it that way. We're going to use that as proof to get the total number of counters, because they gave us the total number of counters. So our simplification will serve as proof for the total number of counters. I don't need to put that as an image there. I can basically type this in. Yeah, because it's quite simple to type in here. I can just type it in there. So that's N plus 1. Or I can use this template right there. And delete this. Right. So we have 11. I put N plus 1, 2 times N plus 1 in the square brackets, and that's it. For the expansion I did, it will help me to prove my answer for the total number of counters. Now, for the number of black counters, it's very simple. N times 1 squared, or N times 1 all squared, and that's it. So now we're going to expand N times 1, N plus 1 all squared, and add it to the number of white counters to see if we get 3n squared plus 5n plus 2. So let's go back there. We're going to calculate n plus 1 all squared. N plus 1 all squared is n plus 1 times n plus 1. N plus 1 times n plus 1. We have to multiply n by n and n by 1. N by n is n squared. N by 1, n times 1 is 1n or n. Now we have to repeat this will be 1 now. 1 times n is n. They call it expanding brackets to obtain a quadratic. 1 times 1 is 1. These two center terms will always be able to simplify. N plus n is 2n. So this simplifies to n squared plus 2n plus 1. Now we have to add this now to the number of white counters to get the total and see if this matches with the total that was given. And that will prove that we are on the right track. So this is the number of white counters plus the number of black counters. And let's see what this gives us. Like terms together, 2n squared plus n squared. They are like each other. Let's bring them together. 3n plus 2n. They are like each other. Let's bring them together. And 1 plus 1 is two constants. So 2n plus n will give us 3n. 2n squared plus n will give us 3n squared. Three n plus 2n will give us 5n. And 1 plus 1 will give us 2. And let's bring this next to the total number of counters that's in the question. Let's see if it matches. Three n squared plus 5n plus 2. So it matches perfectly. So our two answers are correct, meaning number of white counters and number of black counters. They are all correct. So that's the answer for this cell and for this cell.